Okay, here's part 2 of our lesson on Intro to Limits and Asymptotes, and we're on problem number 4. And in problem number 4, we're given some limits, and we have to use those to find the graph as well as the asymptotes. So remember in problem number 3, look at the parts I circled in green. So the limit as x goes to infinity and the limit as x goes to negative infinity correspond to your horizontal asymptote. And notice that it's telling us that the y values are getting close to -2 in both of those cases. So our horizontal asymptote is going to be y equals -2. So we can sketch that on the graph. Okay, and then look at the things I circled in yellow. For problem number 3, those two limits correspond to the vertical asymptote. So notice that to the left of 3, the graph is heading down toward negative infinity, and to the right of 3, the graph is heading down to or up toward positive infinity. So that means that x equals 3 is a vertical asymptote. So we can sketch that in as well. Okay, we're also told that as x approaches 4, the graph is heading toward a height of 0. So that would be over here in this area. Okay, so that could help us. If we put all these pieces together, how about if we draw something like this? So does that fit with this limit, the limit of f of x as x approaches 4 equals 0? Yes. And does it fit with this limit, the limit of f of x as x approaches 3 from the right is infinity, going up toward infinity? Yes, it does. And then on the other side, to make it fit with this limit, we want it to go down toward negative infinity. So we can do something like that. Okay, so for the domain, it looks like it's going through all x values except for x equals 3. However, we actually could have chosen to make our graph have a hole at 4 or to go through 4. We have two options. So if you made a hole at 4, your domain will be different compared with if you made it have to make it go through 4. Okay. So let's just assume that we made it go through the point at x equals 4. So our domain is just x is not equal to 3, and our range looks like the only y value it doesn't go through is the y value of -2, so y is not equal to -2. Okay, let's move on to the next page. We have another one like this. I'm wondering if I make my page a little bit bigger, if that'll work. It's kind of hard to, it's kind of nice if we can see the whole thing. I realize that makes it very small in the video. Sorry about that. So for this one, we are told that the limit as x approaches, okay, I apologize because I had to stop mid-sentence, and so I'm just going to start my sentence over again. We're going to take a look at a couple of these limits here. The limit as x approaches 0 from the left of f of x is negative infinity, and the limit as x approaches 0 from the right is also negative infinity. So those correspond to our vertical asymptote, and it looks like we're looking at the left and right of 0, so that would be x equals 0. So we can draw that in as a dotted line. And notice that both of those were negative infinity this time, so it's going to be going down on both sides instead of up on one side and down on one side. Notice that we're also told that the horizontal asymptote is y equals 3, so we can go ahead and graph that. And that corresponds to the following two limits, the limit as x approaches infinity and the limit as x approaches negative infinity. Those describe the end behavior. So if you recall from the last unit, we talked about end behavior. That is describing what the graph is doing when x approaches infinity and negative infinity. So it looks like those are going to be 3. because we put that horizontal asymptote in place. Something else we're told is that as x approaches 4, the y values approach 2. So we can use that either making a hole or going straight through it. But look at the domain. The domain says x is not equal to 4, so we want a hole at 4, 2. So using that, we can go ahead and draw a curve kind of like so. And then on the other side, remember we need it to go down toward negative infinity on both sides, so maybe we can do something like this. And then let's look at the range. Does what we drew match with our range? Certainly looks like it. Y values from negative infinity to 3. Okay. From this point on, the rest of the problems, or most of the rest of the problems, are asking you to familiarize yourself with rational functions. By using Desmos, you type the function in, you look at the graph, you draw a sketch, and then you can say what the domain and range and asymptotes are and write some limits for it. The first one I've given you here, f of x equals 1 over x. That is your most basic parent function for rational functions, and it's also known as the reciprocal function. So at this point, you're going to grab a device and you're going to use Desmos graphing calculator, and then you'll plot what you see. So I'll just go ahead and assume that you paused and you did that. And here's what you came up with. Something sort of like this, and this. And so the domain is all real numbers except 0. The range is all real numbers except 0. We can draw in a horizontal asymptote. And the equation of that line is y equals 0. We can draw in a vertical asymptote, and the equation of that line is x equals 0. And then here are the limits that I would write. I always like to write the limit of f of x as x approaches infinity, as well as the limit of f of x as x approaches negative infinity. Those describe our end behavior, and we can see that those are both going to be 0. The height of the function is getting close to 0 as x approaches infinity and negative infinity. The other two limits I would write would relate to the vertical asymptote. So I would say the limit of f of x as x approaches 0 from the left, and the limit of f of x as x approaches 0 from the right. You always want to know what's happening to the left and to the right of your vertical asymptote. And looking at the graph, when we're to the left of 0, the y values are going down toward negative infinity. And when we're to the right of 0, the y values are going up toward infinity. I'm going to squeeze that in there. Okay, let's look at the next one. You're going to pause, you're going to graph that on Desmos, and what you will notice is that you have a horizontal asymptote of y equals 0, a vertical asymptote of x equals 2. Notice how that relates to the function. Sorry, that should say 2, not negative 2. And you'll notice that the graph is going like this. I'm just doing a rough sketch without paying too close of attention to any particular ordered pairs. So for the domain, it's going through all x values except for 2. And for the range, it's going through all y values except for 0. And then you can write some limits, like the limit as x approaches infinity of f of x is 0. The limit as x approaches negative infinity of f of x is 0. So those limits relate to our end behavior, and then related to our vertical asymptote, we can say the limit of f of x as x approaches 2 from the left, and the limit of f of x as x approaches 2 from the right. And to the left of the vertical asymptote, it's going up toward infinity, and to the right, it's going down toward negative infinity. Okay, we can do the same thing for number 8. All right, so you put that into your graphing calculator, and you might have to change the window a little bit, or you put it into Desmos or your graphing calculator. You might have to change the window and sort of zoom out a while, and you will notice that the horizontal asymptote is at a height of 1. So that would be the line y equals 1. And if you're zoomed in too close, it might be hard to tell, but when you zoom out, you'll notice that the vertical asymptote is x equals 2. And then the graph is doing something kind of like this. It's dipping down and then going up. So notice it actually crosses its asymptote. And then on the other side, it's doing this. So it's going in the same direction on both sides of the vertical asymptote. So it doesn't go through an x value of 2. X is not equal to 2. Again, look back at the function. Look at the denominator. See if you can see the relationship there. And then the range, it looks like it won't have any y values less than 0. At least that's how it seems according to what we're viewing right now. So how about if y is greater than 0? And then for some limits, let's write the limit of f of x as x approaches infinity, and that's 1. The limit of f of x as x approaches negative infinity, and that's also 1. Remember, those tie in with the horizontal asymptote. And then let's also write the limit of f of x as x approaches 2 from the left, since that's where our vertical asymptote is, and the limit of f of x as x approaches 2 from the right. And to the left of the vertical asymptote, it's going up toward infinity, and to the right, it's going up toward infinity. Okay, and now here's another one that you sketched on Desmos, and hopefully this is what you see. There's a vertical asymptote at x equals negative 2. Horizontal asymptote, y equals 0. And your graph is doing something kind of like this. Again, not being very careful with any particular ordered pairs, just trying to get the general shape. Now you might notice that if you were to factor the denominator, you would get something like that. So actually, we're going to learn more about this next time, but there's actually something else going on. There's a hole in the graph at x equals 2. So we'll be talking about that later, just giving you a little preview. But you can't really see that when you look at it on Desmos or when you look at it on your graphing calculator. So the domain you can get by looking at the function and asking yourself what makes the denominator 0 and not including those numbers. So x cannot be 2 and x cannot be negative 2. So remember we did domains earlier in the year. You can do that just by looking at the function. You don't have to be looking at the graph. And then for the range, we have y is not equal to 0, which we would get by looking at the graph. But now that we know about the hole, we would also say y is not equal to 1. The horizontal asymptote is y equals 0. The vertical asymptote is x equals negative 2. And some limits we could write. We could say the limit of f of x as x approaches infinity is 0. The limit of f of x as x approaches negative infinity is 0. Those correspond to our horizontal asymptote. And then we can also say, because of our vertical asymptote, we can say the limit of f of x as x approaches negative 2 from the left. Notice there's a little minus on both sides of the 2 because we have negative 2 and we have the left. And to the left of the vertical asymptote, it's going down toward negative infinity. And then we also have the limit of f of x as x approaches negative 2 from the right, and that's going to be positive infinity since the graph is going up on the right of that line. All right, let's do this one more. And if you look at the function and you analyze it algebraically and you factor the numerator, you'll notice that there's a factor that cancels. So again, we'll be talking about this more later, but if you cancel that factor, it's going to give you a hole in the graph. So now when you put this in your calculator, all you're going to see is the line y equals x plus 2. So y equals x plus 2 would have a y-intercept of 2 and a slope of 1. So it's going to look like this. Technically, though, it also has a hole in it. You just can't really tell, but there would be a hole at the x value of negative 2 because of the factor that we canceled. Actually, I'm going to back up. Forget that I said that. The hole would be at x equals positive 2. We'll get into that more later. But anyway, if you don't get that from today's viewing of Desmos, that's fine. So the domain would be all real numbers except 2. When you look at the function, you know that 2 makes the denominator 0, so that's how you can get that domain. And if you do have the hole in the graph, then you see that the range is all y values except 4. And then the horizontal asymptote, well, there is none. The vertical asymptote, there is none. In terms of limits, we could still write the limit of f of x as x approaches infinity, and that would be infinity. Notice it just keeps going up. And the limit of f of x as x approaches negative infinity would be negative infinity. Notice the graph just keeps going down. And for 2 more limits, we could say the limit of f of x as x approaches 2 from the left. I'm kind of curious about that hole. Well, that's going to be 4. And the limit of f of x as x approaches 2 from the right, that's also 4, because we're heading toward a height of 4 when we come at that place on the graph from either direction. And the last thing we have in this little booklet is an extension or a challenge problem, an application. And I'm not sure whether or not we'll have time for this in class, but we have it available just in case we have time. And what I'll do is I'll make a third video to describe how we would solve this problem. Thanks.